Okay, so kita akan tengok on properties of liquid. So the one amazing thing yang kita boleh tengok first, tengok this video. Okay. So korang pernah tengok tak yang macam apa benda ni macam nyamuk yang atas air tu? So they are called water strider because they have this amazing ability to walk on water. Okay, why is it possible? Kau Pokemon lah gila. Okay, why is it possible dia nak jalan atas water? Okay, kenapa? Nampak kalau you guys panggil joget ke? Kalau you guys tengok, dia punya kaki is quite narrow, like apa benda tu, jarum. So why wouldn't it just punch the water and terus tenggelam? Okay.
Come on, they're literally walking on water.
So it's basically walking
But come
on water.
down to their level, and it's a bit
Water
more
ibarat
sinister.
yang support dia.
These delicate little bugs have figured out how is those crazy long
So
legs.
if we look dekat those
Water is pretty actually hold you up as long as you
has a
don't break
very,
through that surface
like
tension.
distorted
It
around
seems like the water
legs lah.
strider's legs would just sink right in.
So dah tengok pasal ni. So okay. And kalau you guys tengok kita burette hari tu measuring cylinder, waters kalau dekat edge dia macam melengkung kan. So kita akan tengok why is it. Okay. So mana satu entire screen. Alright. So nampak kan my slides. Nampak ke? Yes, kita akan tengok pasal water tension. So kenapalah air ni tension? Okay. Mana dia pergi? Okay, sini. Kenapa air ni tension? So there's a few properties yang kita akan bincang on liquids. Okay. So the first thing yang kita akan tengok is the learning objective of today's punya liquid. So most of the time kita akan cerita pasal intermolecular forces. Itu kita dah bincang. We have van der Waals and hydrogen bonding. But most likely for liquid kita akan cerita pasal water lah kebanyakan. So kita akan banyak cerita pasal hydrogen bonding. So I can just HB, hydrogen bonding, bukan happy birthday. And then kita akan cerita pasal molecular arrangement. This one you guys dah belajar masa SPM. Motion dia pun. And then kita akan explain dia punya surface tension yang kita tengok tadi. Viscosity, compressibility and diffusion. Okay. So compressibility is very normal. Kita just compress dia. The thing yang kita akan bincang juga is viscosity and diffusion. Viscosity is in layman terms, okay, simple words, is kepekatan dia, okay, is kepekatan, okay. So and then kita akan explain pasal vaporization and condensation process, okay. And another important thing kita akan bincang is vapor pressure and boiling point. What is vapor pressure and what actually the definition of boiling point? When does it boil? Okay, and then kita tengok boiling process. Okay, bila awak boil air, awak nampak the bubbles yang keluar tu, okay, kan? Contohlah air is H2O kan? Those bubble yang keluar is not hydrogen gas ataupun oxygen gas. Okay, those bubbles yang keluar is H2O but in vapor. Kita akan tengok nanti macam mana the formation and how does those are affected by intermolecular forces and vapor pressure lah. Because I akan cerita the more efficient way untuk korang boil air. Nak masak Maggi korang. Okay, first of all, kita akan tengok the properties of liquid. This one, I'm assuming korang kalau korang tak masuk kelas ni pun korang boleh cerita pasal properties liquid. Korang dah belajar banyak sekali daripada sekolah rendah hingga sekolah menengah, right? So it is arranged closely but not rigidly and held together by strong intermolecular forces. Okay, in chemistry, so what you guys are adding to your point, okay, this one korang dah tahu, right? So korang yang jarak sikit tu je kan. But now you guys have to explain it in terms of intermolecular forces. Okay, so apa yang properties of liquid, that this molecule, even though jauh, they are attracted to each other by intermolecular forces. It's either van der Waals, which is kalau van der Waals, we have London forces, or dipole interaction, where London is non-polar, dipole is polar, ataupun we have hydrogen bonding. Hydrogen bonding is only on hydrogen and with F, O ataupun N. Okay, hydrogen yang connected to fluorine ataupun oxygen ataupun nitrogen, itu saja. Okay. Even though ada intermolecular forces, dia orang still boleh move freely. Okay, that's normal. Okay, ini korang dah pernah tengok the shape, korang cerita dia. Okay, one thing yang kita nak cerita sikit pasal surface tension. Alright, so surface tension, why the liquid has a property of surface tension? Okay, all of them experience intermolecular attractive forces kan, tapi dekat surface, okay, molekul yang dekat atas are pulled downwards and sideways from the neighboring molecules. So kita akan tengok ni, but not upwards from the surface. Okay, so yang mana merah ni is the one yang key point lah kalau dia tanya pasal surface tension. Explain surface tension in liquid. So apa yang you guys perlu cerita is semua experiencing intermolecular attractive forces, tetapi molecules at the surface are pulled downwards and sideways. So this is the important thing yang you guys kena highlight dalam jawapan. So molecules at surface ni, they are pulled downwards and sideways, tetapi bukan dari atas, but not outwards away from the surface lah. Okay, so it causes the molecule to be compact dekat atas. Dekat atas, mana pergi? So dekat atas ni, so this is you punya molekul liquid, but dekat atas dia are compact sikit. Dia almost dah macam solid sebab the attractive forces tarik dari semua direction, tapi coming from bawah saja, dekat atas tak ada liquid kan. Okay, so that's why we have surface tension. Okay, surface tension is not directly lah, dia macam related dengan dia punya temperature. Okay, because kalau temperature increase, intermolecular forces ni does not necessarily become weaker. Okay, it become less weak compared to the energy yang this molecule ada. Okay, compared to energy, so kinetic energy this molecule, okay, will become lagi tinggi daripada intermolecular forces. Okay, IMF is a acronym untuk intermolecular forces. Kinetic energy will be higher, so that's why the surface tension will be weak lah. Okay, so kalau you panaskan any liquid, the surface tension will decrease. Okay, so let's look on kenapa kita ada yang surface tension tu. Ni the ayat semua benda yang kita dah tengok tadi. So if you see, molecules yang dalam the liquid are attracted to every single keliling dia akan ada attraction force. Tetapi untuk dekat surface, this is the surface, the molecule yang paling atas ni only attracted dekat bawah and tepi. So it will compact dekat top. So that's why we have surface tension where the nyamuk boleh letak kaki dia tu. Okay. Bayangkan itulah nyamuk orang tu. So dia boleh berdiri dekat atas surface tension tu. Right. So after surface tension, kita akan tengok on the viscosity. Viscosity or the kepekatan lah. So apa itu viscosity? So anyone here yang dah ada kereta and pernah tengok minyak enjin? So, minyak enjin, kalau siapa sini yang dah ada kereta ataupun pernah ikut parents dia pergi servis kereta, so minyak enjin usually dia akan ada grade. So contohnya 0W15 ataupun 510 ke macam tu. So this number 0W15 ke ataupun 5W10 ke ataupun 20 ke semua tu is dia punya measurement of viscosity, kepekatan minyak. Okay? Because different engine perlukan different kepekatan minyak. Ada engine perlukan minyak yang tak pekat sangat. Okay. So why liquid can have a viscosity, which is kepekatan. Okay. Kepekatan is an intrinsic characteristic of liquids, right? Because kalau you remember, the liquids are ada separation. So the molecules can move past each other, okay? But different type of molecule, contohlah lagi besar, contohlah the molecule tu lagi besar, it will have harder time untuk move past each other, kan? So it will have higher viscosity, dia lagi pekat. Ataupun another factors yang affect viscosity is the intermolecular forces, right? So kalaulah the intermolecular forces tu kuat, so the attraction between each of the atoms are stronger, right? So it will be harder untuk this molecule to move past each other. So that's why we have like macam different grade. Okay, maybe this oil have higher intermolecular forces than this kind of oil. Okay, so what can affect dia punya viscosity is dia punya temperature. Kenapa? So bila higher temperature, which kita can almost relate it directly, will have higher kinetic energy. So lagi banyak temperature, lagi tinggi temperature, the more energy kita put into the system. So dia punya molecules can move faster past each other. They can zoom past each other. So the intermolecular forces dah become a bit negligible. Kita dah boleh move past it. So the viscosity jadi makin rendah. So actually kalau tengok oil, kalau contoh 0W15, so 0 is when engine awak sejuk and 15 is the operating temperature bila you guys dah berjalan jauh ataupun engine awak dah panas lah. So maksudnya, tapi does it make sense kenapa at lower temperature dia lagi cair, tapi as higher temperature dia jadi lagi pekat? It does not make sense dengan kita punya argument sini. Dia cakap bila temperature bertambah, viscosity berkurang. Tapi kalau minyak kereta, viscosity bila temperature dia tinggi, dia lagi pekat. Anyone have any idea ke? Minyak motor ke, minyak kereta ke, most likely the same. Dia ada apa benda tu, ada dia punya number 0, 15, 10, 20 semua tu. Anyone have any idea kenapa as temperature tinggi minyak tu lagi pekat? It does not make sense. Sepatutnya temperature lagi tinggi, lagi kuat, lagi laju dia gerak, it should be less viscous. It should be less cair. Dia jadi lebih cair. Anyone have any idea? Any idea? Korang rasa? Apa idea pun tak apa. Don't worry, kita akan bincang. Yes, telur rebus is a good one. Telur rebus. Okay. Dalam minyak, we don't actually have water. Okay, maybe liquid to vaporize. Alright. So, the closest answer yang I've seen so far is about the telur and lagi satu minyak terdiri dari molekul lain. Okay? Even di molekul besar pun, as high temperature, it can easily pass each other. Okay, so in minyak or telur is actually we have a called a polymeric punya molecules, right? So sekejap. Yes, but minyak and telur is a special case. Mana hala saya punya ni? Sini. Okay. So in minyak, so we have kalau minyak enjin, so we have a polymeric punya structure where dalam the molecules, so we have a bunch of polymers yang entangle each other lah. Dia macam spaghetti ataupun macam Maggi lah. Okay, dia macam Maggi. So as temperature increase, this polymer pun dia jadi untangle, dia jadi panjang. So what happen? This polymeric punya structure, okay, polymeric ni you guys akan baca on chapter 13 next semester. Okay, where dia orang akan entangle each other. Macam Maggi dia bercantum dengan Maggi lain. So that's why dia jadi makin pekat. Okay. Same as telur. Telur pun have those kind of property where as temperature increase, this structure entangle with each other. Okay. So macam rambut korang yang rambut luruh tu dekat atas lantai tu banyak-banyak dia akan tergumpal. So that's why as temperature tinggi, the viscosity pun jadi makin tinggi. Okay. Sebab kan benda ni dia gerak lagi laju, dia lagi tergumpal dengan yang lain, right? Okay. But that is only for minyak and telur macam tu lah, on the special case. Okay. Tapi soalan dia selalunya akan tanya a basic relationship. Okay. The basic thing yang kita need to know is temperature bertambah, viscosity berkurang sebab intermolecular forces dia pun dah tak boleh nak overcome dia punya kinetic energy. Okay. I'm just telling you about the minyak and the telur because kita tahu soalan sekarang kadang dia orang akan tanya high order thinking. Okay. So that is one example. Okay. So kita cerita pasal viscosity, kita nak cerita pasal compressibility. So dalam bahasa Melayu ni keboleh mampatan. Alright. So macam hari tu kita dah tengok gas, right? You punya experiment, we have a piston here, right? Have a gas, and we can move the piston relatively easy lah. Tapi now if we have liquid, okay, you boleh nampak why it should be a bit harder untuk compress, right? We have more molecules in a closed space, okay, and these molecules also kalau boleh kita nak mampat pun actually don't actually have much place untuk pergi pun, so they will bump each other. That's why it's harder comparing dengan gas where there's a lot of empty space, kan? So itu je. Usually korang the compressibility dia orang akan tanya pasal gas, liquid and solid. Ni soalan ada masa SPM dulu. Okay. So itu je. You just cerita about the empty space. We will have a less and less empty space. Okay. Comparing dengan viscosity, most of yang kita punya arguments kita akan cerita pasal intermolecular forces and kinetic energy, right? Those two. Untuk surface tension pun kita akan cerita both of this stuff lah. Okay. And what about diffusion? Okay, this is a new word. Okay, diffusing. Okay. Tengah ada, I don't know whether korang ada or not the gas diffuser apa semua tu yang orang letak essential oil tu. Okay. Those are not actually diffusion lah. Those are actually vapor. Okay. So what is actually diffusion? Okay. Diffusion is when dia bercampur. Okay. So actually untuk liquids, they are slower untuk bercampur than gas. Okay. One example. Contohlah dalam kelas. Okay. Saya duduk depan, korang duduk belakang, and then suddenly saya terkentut. Right? Even though korang tak dengar, but later on you guys akan bau kan. Okay, bau my breakfast or anything yang I makan. Right? But kalau gas, kalau liquid, it takes longer untuk dia diffuse to the air lah, contohnya. Contoh kalau macam, comparing kalau you terkentut and you terkencing. People will smell your kentut first before people will smell your kencing. Right? That's how. Okay? Because molecules untuk yang liquids, right, they are packed closer to each other compared to gas, and they actually have lower kinetic energy. Right? Mana highlight? Okay, lower kinetic energy. So they actually move slower. Okay, and dia punya intermolecular forces pun are stronger within liquid. So the same arguments that you use untuk cerita pasal viscosity, pasal surface tension also apply on diffusion. Okay. Diffusion is just a simple term is mixing lah. So maybe liquid dia diffuse dengan gas ataupun liquid dia campur dengan other liquid, like that. Okay. So this is kalau you guys nak buat note, you guys boleh buat guna this table. So we have our properties of the liquids, and we have the description of the liquids. So we have volume and shape. So the same thing you guys belajar masa SPM, and compressibility only slightly, because yes, water or any liquid boleh compress. It's very hard, but you still can compress lah. Density is high. Okay, motion of the molecules, kita boleh slide past each other sebab ada still a free space kan. So ability to flow is basically what we are discussing about viscosity, and this is dia punya general. Kalau you nak terang, contoh dia akan bagi tahu pasal maybe about fluorine and bromine. Okay, so fluorine is smaller than bromine. Okay, so contohlah dia bagi cakap compare the viscosity of liquid fluorine and bromine. But usually dia orang tak akan dalam liquid lah, dia orang akan dalam bentuk gas. Tapi example lah, contoh soalan tu tanya. Okay, apa yang you guys boleh cerita is shape and size. So fluorine is smaller while bromine is bigger. Okay, and then so as size increase, viscosity increase. Sebab apa? Okay, kalau gas tu besar, it will be harder untuk dia orang pass each other. Comparing kalau gas tu kecil, gas pula, kalau liquid tu kecil. Kalau liquid tu kecil, it will be easier untuk dia pass each other. That is what viscosity is. Okay. And intermolecular forces pun you boleh cerita. Kalau comparing macam polar ke, contohlah kalau the comparing between HF punya liquid dengan CH4 punya liquid. Okay, methane punya liquid dengan HF punya liquid. So HF is a polar molecule, and also dia boleh buat hydrogen bonding, while this is non-polar molecule, and they only have van der Waals forces. So obviously hydrogen bonding is stronger. So this one will have higher viscosity, while this will have lower viscosity. Okay. And temperature of the liquid. So what we are explaining about temperature of the liquid. Okay. So untuk temperature, we actually have to use two points. Apa benda ni tak nak keluar. We have to use 2 points untuk cerita pasal dia punya viscosity, how temperature affects. Okay. Because as temperature increase, kinetic energy of dia punya molecules also increase. So we can go past through the intermolecular forces. So intermolecular the kinetic energy can overpower the intermolecular forces. That's why viscosity jadi makin rendah. Okay. Tapi we only have two special kalau contoh minyak enjin. So engine oil. In. Okay, saya lupa cara nak edit engine pula. Okay, we have engine oil dengan telur. Right? Or eggs. So the key point untuk jawab contoh soalan dia tanya pasal benda ni is you guys cerita pasal polymer, which is dia orang panjang. The higher the temperature, lagi entangle dia orang. Sebab polymer ni memang panjang-panjang. So contoh another polymer is you guys punya plastic bag. That is another polymer. Apa lagi? Plastic. Okay, pipe PVC. It is a polyvinyl chloride, which is also a polymer. That's one example. Okay. So the process that liquid can jalan, okay, jalan, can occurs, can experience. Okay. So we have vaporization and condensation. Okay. Now we are not just explaining vaporization to apa, which is liquid kepada gas, and then condensation is gas ke liquid. That is sekolah punya level, right? Now we are explaining the chemistry behind it. Okay? Liquid ke gas, right? So we are explaining in terms of a theory that we call kinetic molecular theory. Okay, this theory is just that actually kita already dah use this theory. Okay, soalan nanti dia akan tanya, okay, based on kinetic molecular theory, explain. Jangan cuak, jangan alamak, apa benda kinetic molecular theory ni? Relax. Okay, we already dah explain, we use lah. Okay, because what we are using this theory is kita are talking about dia punya kinetic energy, okay, and dia punya motion of the particles lah. Okay, the higher temperature, okay, lagi tinggi kinetic energy. Thus, what happen lah, contoh macam kita cerita pasal dia punya viscosity ke, dia punya surface tension ke, like that lah. So, at higher temperature, the molecule will have sufficient energy untuk overcome the forces. Benda yang sama dia cerita tadi. Okay. I'm just telling you that kalau soalan tanya pasal kinetic molecular theory, jangan cuak. It's the same thing. You just cerita pasal kinetic energy. Alamak, tak nampak. So, kinetic energy, okay, how it relate with the temperature and also how it can overcome the intermolecular forces. Itu sahaja. So, these two, you just hafal satu and you will can explain the other one. So vaporization is temperature increase, right? Condensation, temperature decrease. So untuk temperature increase, kinetic energy pun increase, right? Untuk temperature decrease, kinetic energy pun decrease. Okay, untuk jawab soalan nanti, you cannot jawab macam temperature macam ni, and then you cakap kinetic energy. You tak boleh jawab macam ni tau. This one is only untuk notes you boleh cerita macam ni lah, temperature, kinetic energy. Tapi boleh. Kalau you nak tulis macam ni pun boleh. Tapi you still have to buat ayat lah. So at higher temperature, the molecular process sufficient kinetic energy to overcome the attractive forces ataupun the intermolecular forces. So kalau I suggest to you guys, terus tulis macam ni. Just buang masa kalau you guys nak tulis ini and then kena tulis balik. Because kalau you guys jawab macam ni, you guys will not be given any marks. Even though betul, the pemeriksa faham 100%. Tapi dia akan buat tak faham. You have to buat ayat, a complete sentence, right? So these two just tertukar je lah. Satu temperature naik, kinetic energy naik. Satu temperature turun, kinetic energy turun. Thus, it cannot overcome the intermolecular forces. The intermolecular forces will be stronger than dia punya kinetic energy. That's why it jadi clump together, thus becoming liquid balik daripada gas. Very simple. You just know that we have apa point yang kita cerita. Kita kena cerita pasal temperature, kinetic energy and intermolecular forces. These 3 points mesti ada, and you just cerita which one naik, which one turun, and what happen lah. These two. Okay. Semua okay ke macam tu? Because I nak masuk vapor pressure. Ada any confusion? Ada bau telur? Oh, yang tadi ke? Okay. Any confusion so far? I think this one is very simple topic to understand. Okay ke? Okay ke anak-anakku? Bakal-bakal 4 flat ni okay ke? Alright. So okay kan? So okay, I nak terangkan because ada a few confusion lah. Okay, hari tu yang saya cerita, untuk exam, satu soalan, satu page, kan? And then you boleh jawab in bullet point. So, bullet point you boleh jawab, you boleh guna. Tapi make sure sentence tu you penuh. Jangan sentence sangkut-sangkut. Sentence sikit, okay? Okay, untuk assignment yang you guys buat tu, soalan dia pendek kan? Boleh je campur dalam satu page tu ada 2-3 soalan. Boleh je. Okay? I'm just telling you guys hari tu, satu soalan, satu page tu untuk exam. Soalan exam mesti guna satu page, satu soalan. Sebab nanti you will annoy dia punya pemeriksa. The number one thing that you does not want to do is annoy the pemeriksa. Okay? You kalau boleh nak tulis cantik-cantik, guna banyak colour so that pemeriksa tu sejuk hati. Okay, untuk yang assignment, kalau you dah tertulis tak apalah. Kalau siapa yang guna words tu, bolehlah nak masukkan balik untuk satu page tu untuk semua soalan ke kalau cukup. It's okay. Doesn't matter. It's as long as you guys jawab semualah. Okay. What I'm telling you is soalan untuk exam. Okay. So, let's go. Tak apa, don't worry. As long as jawapan you betul, saya okay je. Okay. So, kita akan tengok vapor pressure. Okay. Vapor pressure is a new thing yang kita akan belajar. And what actually vapor pressure is, okay? Is the vapor pressure is the pressure that exerted by the vapor of dia punya liquid in a closed container. So, apa benda tu? So, imagine this is a beaker. So, we have a beaker. And then kita letak air apa? So kita letak roasted milk tea with grass jelly daripada Tea Life. So itu warna ni lah. So kita letak lah. And then adalah boba dalam ni. So tapi kita tutup dia punya beaker tu. So beaker tu ditutup. Okay. Tutup and it is a complete seal. Tak ada udara boleh masuk, tak ada udara boleh keluar. Vapor pressure is the pressure of dia punya warp, okay? Dia punya warp yang actually this liquid, any liquid, dia always akan ada interchange with the gas kat atas. So the gas yang dekat sini is the vapor pressure. Okay, the vapor pressure is the gas yang akan tolak sini lah, tolak all the dinding dia. This is the vapor pressure. Okay, so every liquid have dia punya vapor pressure kalau in a closed container. Okay. Apa factor yang affect pressure of dia punya warp ni? Okay. As temperature increase, the molecule gain energy, which is kinetic energy. Okay. So, lagi banyak molecules yang boleh escape to the from the surface untuk jadi vapor pressure. So, apa benda sebenarnya ni? Okay. Remember tadi, we have a beaker and we have what? Contoh liquid. So, sebabkan tadi kita ada surface tension, a lot of molecules are more compact dekat surface. That's why we have surface tension kan. And we have molecules yang dekat bawah ni lah, right? So as we heat up the molecules, kita panaskan, right? So as we heat up the molecules, those molecules we have more and more kinetic energy untuk pass the barrier ataupun pass the attractive force of the intermolecular forces untuk dia menjadi vapor. Okay, dalam this is a closed container untuk dia jadi vapor. So lagi tinggi temperature, okay, the temperature increases, the vapor pressure also increase because we will have more and more molecule escaping from the liquid to become a pressure. Okay. Another factor for instead of temperature is the intermolecular forces. The stronger the intermolecular forces, we will have less vapor pressure. Okay. That's why kalau it is weaker, okay, kalau intermolecular forces dia weak, they only have, contoh example, I give London forces. London forces is the weakest kan, because we have dipole, and we have hydrogen bonding. This is dia punya relative strength. Okay. Contoh dia only have London forces. London forces is only for non-polar molecule kan. So contohlah macam methane punya liquid is very weak. Thus kalau kita letak dalam seal container pun, okay, dia punya vapor pressure will be stronger than kalau kita letak contoh water. Okay, water, kita letak water. Okay, this is water. Okay, dia punya vapor pressure untuk water is very weak compared to the vapor pressure of contoh methane, CH4, which is dia punya intermolecular forces is weak, while water we have hydrogen bonding is very strong, so susah the molecule nak jadi pressure, while methane senang je. Okay? Dia macam ni lah korang ingat. So korang ada parent yang strict ataupun korang ada parent yang chill. Kalau parent korang strict, susah kan nak keluar, nak pergi movie. Okay? Kalau parent korang strict, kalau parent korang chill, nak pergi movie, dia bagi je, dia bagi duit. Macam tu lah. Okay? So we have two thing yang kita akan bincang. We have temperature and intermolecular forces. Okay? Benda yang sama. We have temperature, kinetic energy, and intermolecular forces. Untuk liquid, we always bincang benda yang sama. Temperature, tiga benda ni. Okay. Diorang ni macam tiga sekawan. Okay. Korang tak tinggal satu pun. Now we get into the fun part, which is boiling point. Okay. What actually boiling point? What actually happening during boiling? Apa-apa yang you guys boil. Sometimes diorang akan tanya the definition of boiling point. Okay. So this is the thing you guys have to take note, where boiling point is where dia punya vapor pressure, okay, equal to external pressure. Okay. So vapor pressure dia, which is the pressure in the closed system tu, equal dengan dia punya external pressure. Okay. So sekejap, saya minum air sekejap. Tercekik saya. Okay, normal boiling point is at atmospheric pressure lah. So kita talk about ATM, which is 1 atmospheric pressure is the pressure yang kita rasa dekat sea level. Okay, so boiling process. What actually happening during the boiling process? Mana datang buih-buih tu? Mana datang all the bubbles? Right? So the bubbles came from this process. Okay. Boiling process is where kita tukar daripada liquid ke gas kan. That's normal. Okay. But now what happening? Those gases, those molecule can spread far apart. Okay. Sebab dia orang ada kinetic energy higher kan. So dia orang boleh gerak jauh. So bila dia orang jauh enough, okay, this molecule ni, contoh this is water molecule. Bila dia orang dah jauh, so So instead of being a liquid phase, diorang dah jadi gas phase. Okay. So this is not hydrogen gas, this is not oxygen gas, this is water gas. Gas punya vapor. Okay. That's why dia jadi bubbles. Okay. So boiling is a physical change and molecules are not chemically altered. So maksudnya dia tak tukar pun jadi hydrogen gas, oxygen gas. Still water. Alright. So let me illustrate dia punya process with my amazing drawing. So we have put, oh my god. Okay, we have a beaker. Okay, and then we have water molecule. So saya just represent water molecule macam bulat lah. Okay, bulat. Okay. Okay. So like kita cerita tadi, so at the surface the molecule are more packed, closer sebab of surface tension. Okay, a phenomenon of surface tension sebab intermolecular forces dia tertarik between side to side and downward saja. Okay, while molekul yang dekat dalam air tu bukan not in surface, are spread further apart sebab kita have the intermolecular forces yang tarik from all direction, all 360 degrees direction. Okay, fair enough. Okay, now kita nak explain the process of boiling. Okay, at room temperature, okay, at room temperature we also have atmospheric pressure. Okay, the pressure of atmosphere yang push the air, push the liquid downwards kan. So dia punya the gases, the molecule tak boleh keluar. So this is atmospheric pressure. Okay. But here on top of your liquid, any liquid, we have a layer of vapor pressure. Oh sinilah. Oh sini. Okay. We have a layer of vapor pressure where sini on top of the layer we have those molecule yang escape. Yang contohlah yang tiba-tiba ada orang give energy. Right? Orang give energy which is ataupun heat it, okay? This is other molecules yang have enough kinetic energy to overcome the intermolecular forces to become pressure, vapor pressure. We have a few. Okay? Dia always ada. At any temperature, always ada. Kecuali dia dah jadi solid lah. As long as it is liquid, dia always ada a thin layer of vapor dekat atas. Or we call it vapor pressure. So, what actually happened masa boiling? Masa boiling, so we keep giving it more and more heat. Okay, temperature keep increase, and then kinetic energy pun keep increasing. Okay, so what happened in turns, vapor pressure pun increase lah kan. We have more and more escape molecules. Now, what happened when boiling is when we actually have the vapor pressure. Okay, the vapor pressure is equal. Tak nampak sakit mata saya. Color apa color ni lah. So the vapor pressure is equivalent to the atmospheric pressure. Okay, so boiling at boiling point, okay, vapor pressure is equal to atmospheric pressure. Okay, so at this point, okay, dah ibarat dah tak ada layer yang dah tak ada pressure yang tolak dia downwards lah kan, sebab dia punya pressure dah sama. So pressure ni pun dah sama. So ibarat all of this dah jadi equivalent to dia punya vapor pressure. Color dia merah lah pula. Cepat nak tekan H. Okay, sini. So, sini pun dah equivalent. So, it is freely moving. Okay. So, at this temperature, the molecule pun yang dekat surface ni pun also dah experience the intermolecular forces dekat atas kan. Atas pun dah ada molekul banyak. So, dia dah tertarik. So, this molecule actually are more free, lagi senang nak bergerak. Okay. So, lagi senang untuk this kind of molecule untuk spread further from each other, okay, to a point that they are no longer liquid. Okay, so that's why ada bubbles. Okay, those bubbles sebab molekul sudah spread as far apart as each other. Okay, so that's why we form bubbles. Kalau you guys tengok, kalau you guys boil air, so that's why those bubbles. Usually those bubbles are formed dekat bawah kan, dekat buntut. No, bukan buntut. Base of the pan ataupun mangkuk periuk orang. Sebab that is the hottest part. That is where those molecules have the highest energy untuk move apart from each other. That's why we have bubbles. And when you have bubbles, bubbles are less dense than water. So dia kalau dia meletup ke atas. That is, you know when it is bubbles. So, what are the tricks untuk making your water boil faster? Okay. So, give me an idea macam mana you guys nak boil you punya air faster. Ada air? Okay, good. Supply more heat. Right? Tambah benda asing. Actually, okay Sam, kalau kita tambah benda asing, contohnya salt. Okay, you guys nak buat spaghetti. Right? You tambah salt, we actually are increasing the boiling point. Dia lagi lambat nak boil. Okay? So that is one thing yang a qualitative measurement of you punya barang. Contohlah nanti you guys akan nak belajar engineering ataupun chemical engineering. Okay, you dapat you punya compound, and then you tengok dia punya boiling point, okay, is not sama dengan dalam buku. Okay, nanti you guys akan tengok we have a list of all of the compound in the world and dia punya boiling point. Okay, kenapa you guys punya barang is have higher boiling point than dalam stated in buku? Because dia ada contoh salt ataupun apa-apa yang benda asing lah. Those stuff, okay, contohlah you ada salt. Salt, kalau you guys remember, kenapa kita tambah salt dekat spaghetti? Sebab kita nak increase boiling point. So the spaghetti dia masak at higher temperature. Sebab salt is NaCl, sodium chloride. Okay, sodium and chlorine is a very polarized term. Okay, so actually dia tarik the water molecule to each other dekat-dekat. So dia tak nak keluarkan. So those molecule nak keluar tapi dia tarik. So dia tak boiling lagi. That's why kita have higher boiling point actually. Okay, untuk lagi cepat dia boil, okay, first is tutup periuk like Agus Man cakap. It's true. So we can increase the temperature, which is kita increase dia punya kinetic energy, lagi cepat, lagi banyak vapor pressure, lagi cepat lah dia boiling kan. Ataupun kita tutup periuk so that the vapor yang sini dah tak banyak kan. So lagi cepatlah the vapor pressure dekat atas ni untuk jadi the same as all this area. That is one thing. Because kalau you guys tak tutup periuk kan, this is you punya water, you punya vapor pressure is here. Lepas tu dia lagi tinggi jadi here. So lambat untuk dia equalize dengan the whole of you punya dapur ni. That's why nak cepat boil, tutup. Ataupun one other thing that we can do is have a lower atmospheric pressure. So kalau lah pressure yang tekan you punya molekul daripada keluar rendah, it will be easier untuk all this molecule keluar as vapor pressure and thus in turn boil kan. So So that's why kalau you siapa yang hiking atau pergi camping, you masak air dekat atas gunung comparing to the sea level, masak air dekat rumah, masak air dekat atas gunung is easier untuk you boil. Okay? Even though the temperature is less than 100 degrees. Kan kita tahu temperature untuk water dia boil at 100 kan? Because dekat atas gunung we have less pressure, less atmospheric pressure dekat atas. The higher you are, the less pressure you have. So it's easier untuk dia boil. Okay. Okay, untuk heat, specific heat capacity also correct. Nanti kita akan belajar pasal thermochemistry. That's also kita akan belajar. And now that's why kalau siapa kat rumah ada pressure cooker, actually you cook faster guna pressure cooker. Sebab it has lower pressure, so kalau apa-apa benda dalam tu dia akan boil faster. That's another thing lah. Okay, and this is a words of apa yang saya cerita tadi lah, in word form, which is kalau dia tanya pasal boiling process, you guys boleh lukis ataupun you guys nak buat words. In my opinion, you guys campur lah the better. So you get lukis and then you labelkan apa yang you lukis, right? You labelkan lah, or this like maybe this is water molecule, H2O molecules, and then this is intermolecular forces, which is hydrogen bonding, and then this is vapor pressure. Macam tu lah. Kalau nak lukis boleh, you labelkan. Tapi kalau you guys nak jimat masa, terus tulis pun tak apa. So, apa yang saya terang tu in words form. So, when boiling occurs, more energetic molecules change into gas. Senang nak spread out. Okay. So, energy required untuk change from liquid to gas is supplied by the heat. So, it's easier they nak overcome the water particles in increasing kinetic energy. Thus, the temperature of the liquid remain constant during boiling point. Itu je. So, kalau you guys tengok, from solid, kita contohlah ice jadi liquid, dia akan stay at the temperature, and then kita keep increasing the temperature, dia akan start untuk 100 degrees Celsius, boiling temperature, sampailah all of the liquid jadi gas, then baru temperature dia akan naik. Okay. So, that's it untuk liquid. So, any question about liquid? Just hari besok kita akan masuk on gas. Mana ada gas? Kita akan masuk on solid and phase diagram, where graph yang you guys kena lukis untuk phase diagram. So, any question ke? Ada soalan? Periuk nasi elektrik. Okay, periuk nasi elektrik, korang letak, dia panaskan guna elektrik kan, so the whole thing akan panas. So, macam mana dia tahu bila semua air tu dah tak ada? Korang perasan tak kalau periuk nasi air, periuk nasi, okay, dalam dia ada macam tengah-tengah tu like a spring pipe. Dia macam bulat, ni ada spring pipe. So, you letak periuk, dia akan tuk. So, how they know air dah habis? Sebab bila you dah masak nasi, those air turn into vapor pressure kan. And then from the vapor pressure, dia akan turn into all gas. Okay? So, all of the water will lose out. Okay? Dia akan keluar. So, dia akan jadi makin ringan. So, bila makin ringan, dia akan naik. So, that is when dia akan tutup. So, it's just the simple thing. Simple spring thing tu yang decided bila dia masak ataupun tak masak. Itu je. Because all the water evaporated away. Semua okey ke? Okay. Kalau nak the real explanation of vapor pressure, okay, diorang define vapor pressure in a closed container. Okay, because the pressure Kalau in open container, you tak boleh sangat nak kira pressure dia. Okay. Mana ada ni? Okay, sekejap. So, kalau in an open container, all the molecule just will fly away kan. Kita actually don't have a way nak kira dia punya pressure. So that's why kalau vapor pressure, dia punya definition in closed container. Sebab pressure is kita punya measurement of how in a closed container, how many times the molecule langgar dia punya dinding. Okay, the more molecules langgar dinding, lagi tinggi pressure. That is pressure lah basically. Okay, so the definition of vapor pressure is in a closed container. Okay, tetapi doesn't mean kalau open container tak ada vapor pressure. Ada. Okay, ada vapor pressure, a thin layer of vapor pressure. It's just that the definition is enclosed lah, because that is how kita kira pressure. Is kita kira the amount of times, not the amount of times, the amount of molecules yang langgar dinding. Ada bulatan lah. Apa benda bulatan ni? Okay. That is So at vapor pressure, yang the molecule yang jadi vapor pressure tu, yang atas the layer tu, is not actually gas yet. It's not actually water. Not actually liquid. So it is in between. Dia macam dia tak tahu whether dia nak jadi air, dia nak jadi liquid ataupun gas. Dia in between. Tetapi once dia dah sama, semua dia jadi, and you keep applying heat, now and then barulah dia confirm, oh aku sebenarnya nak jadi gas. So that is when dia jadi gas. So condensation is daripada gas kepada water. Okay, condensation is you punya hujan tu, hujan setiap hari dekat Sarawak ni. That is condensation, betul? Gas. Okay, all the cloud. Okay, remember we only have cerita pasal 3 things: temperature, kinetic energy, intermolecular forces. So, bila temperature rendah, nak hujan, sejuk, kinetic, tak boleh guna jari ni, saya guna jari ni. Okay, so, bila temperature awak rendah, kinetic energy awak pun rendah lah kan. So, kinetic energy rendah, the molecules cannot overcome the intermolecular forces. So, intermolecular forces tarik dia orang together. So, dia change phase. Daripada awan jadi water. So, daripada gas jadi liquid. That is how. Boleh ke? Yes. Tomorrow tak ada lab. Okay. Kita akan masukkan solid. And then untuk hari Khamis, kita akan buat another revision on chapter 5. Or tutorials. Okay. Mana-mana soalan tutorials yang you guys tak faham untuk hari Khamis, bagi tahu saya cepat-cepat, kita akan bincang. Ataupun soalan past paper. You guys jumpa soalan past paper, nak tak faham, kita boleh bincang. Don't worry, hari Khamis. Because after that you guys cuti kan. And UPS semua, practical test semua after korang masuk. So don't worry. Okay, so far tak cukup. So korang most likely korang masuk akan buat online class. So kita akan buat online class dulu. And nanti kalau kita buat physical class, korang akan terbahagi lah. So that's why korang ada contoh K1 T1 ada A dengan B. K1 T2 pun ada A dengan B. Dan T3 ada A dengan B. So macam tu lah korang akan terbahagi. Walaupun terbahagi, korang akan jumpa saya juga. Lecturer korang yang handsome ni. Jumpa saya juga. Itu je, korang akan terbahagi. Which is korang takkan ada together lah. Macam ni. So if no other question, jom masuk Discord. Kita nak ambil attendance. And then any question, tanya situ. Yes, absolutely. Jadual akan berubah. Untuk 18 hari bulan tu pun jadual lain. Kita instead of ada 3 jam, ada 4 jam. Okay. Jumpa dekat Discord. Any soalan, tanya kat Discord ya. Okay, bye-bye.